Welcome to today's GATE coaching class. I am N.Magadevi, Associate Professor, Triple Department. Today we are going to see about the electromagnetic fields. First topic, Coulomb's law. So before going to this section, why we are going for the electric field, magnetic field and the electromagnetic field. So this is the main important thing. When the charges are stationary, we know very well what is meant by charge. When an atom or group of atom contains excess or lesser number of charges, then we call them as charges. That is, when an atom or group of atom contains excess or lesser number of electrons. We know that in the atomic structure there are three basic charges: electrons, protons and neutrons. Electrons are negatively charged particles, protons have positively charged particles and the neutrons have no charge. So if the charges are stationary means there will be electric field around the charge. So that only we dealt in the last class about the electric field. And next one is, if there is electric field, how it will be. So charge means it may be a positive charge and a negative charge. If it is a positive charge means the electric flux lines will be radially outward direction, just like lines like that. If it is a negative charge means all the flux lines will be towards a charge, that is, it is also a radial line. So we will have the radially inward flux or radially outward flux, both are electric fields only. And the next second one is magnetic field. So how the magnetic field is created? When the charges are moving with some particular velocity, it may be a positive charge, negative charge. When it is moving with some particular velocity, there will be a magnetic field around the charge. And okay, how the flux will be, how the magnetic flux lines will be means, if it is a positive charge means all the flux lines will be in a circular path in the clockwise direction. And if it is a negative charge, all the magnetic flux lines will be in the counterclockwise direction. So this is the main difference between the electric field and magnetic field. Electric flux, magnetic flux. Electric flux radially inward or radially outward, it will be just like a straight line. And if it is a magnetic flux lines means it will be just like a curved path. Why it is so means we know very well. Magnetic flux is nothing but if you are having the north and south pole, fluxes will be originated from the north pole and terminated at the south pole. The same principle is used here also. That is a magnetic flux. And third one is that when the charges are accelerated. So we know very well what is meant by acceleration. So if the charges are accelerated means there will be electromagnetic field. So what is a electromagnetic field? Electric field will be there and also the magnetic field will be there. That is equal H. So that is where electromagnetic fields. So it is very, very important to know about these topics because it is a basic concept in the electromagnetic fields. So this Coulomb's law comes under the electrostatic fields. So Coulomb's law, who is Coulomb? He is a scientist. He given the force between the two charges. So what will be the magnitude between the charges? What will be the direction of force? In which direction it will be acting? All the things he had given experimentally. He done experimentally and given for us also. And the next one is electric field intensity. It is nothing but the intensity. That is, if you are having the light energy means at each and every point there will be a photons. Its intensity will be varying. Similarly, it may be electric field or magnetic field, there will be a intensity. So if it is a electric field means it is called as electric field intensity. If it is a magnetic field means it is called as magnetic field intensity. So electric field intensity is E and magnetic field intensity is given by H. And the next one is electric flux density. Similarly, we know very well what is a density. You can take any physical quantity per unit volume. It is given by the density. It is nothing but the density. So here also we are having, if it is a electric field, electric flux density. If it is a magnetic field, it is magnetic flux density. Electric flux density represented by D, magnetic flux density represented by B. So it is important thing. And the next one is Gauss law. We will see in the next topic. That is your Coulomb's law. Coulomb's law. So if you are having two charges or so many number of charges in space, if you are taking a space means there are so many number of charges will be present. Here also there is a light energy, there is a flux lines And if you are having this one, you will have the magnetic field. If I am talking means it will reach your ears by means of electromagnetic fields. So all the things will be there in the space. So in this space you may have so many number of charges. We cannot able to see it directly. If you are having two charges, for example, you are taking two charges, and also the charge may be distributed in a single dimension or two dimension or three dimension. Based on that, you may have the point charge represented by Q, and or others you may have the line charge. It may be distributed along a straight line. It is called as line charge, some coulomb per meter, or we may have some surface. That surface it may be a rectangular or any other regular or irregular surface. It is called as a surface charge, or others we can have a volume charge. In a particular volume you have to consider, and it is called as a volume charge. So it may be of any type. It may be of any charge, positive charge, or it may be a negative charge. If you are having more number of protons, positive charge. If you are having more number of electrons, it is called as negative charge. So they may have so many number of charges. So if you are having the two charges, for example, if you are having a positive charge here and if you are having a negative charge here, means automatically it will attract. It will be attracted. There will be a force of attraction between the two charges. Or otherwise, if you are having both are same charges, both are positive charge or both are negative charge, means there will be a force of repulsion between the two charges. So anyhow, we will have the force. It may be force of attraction or force of repulsion. So Coulomb given the magnitude and the direction of that force. So he is telling the statement. So the force between the two charges which are separated in vacuum or free space. Based on the media also the force will differ. If it is a vacuum, the force value will be one thing, X value. And if you are having immersed in oil, inside the oil also we may have the charge. Or otherwise in water there are so many number of molecules and the charges. So based on the media also, because why it is varying means the media. So if you are having some dielectric media, or you may have so we know very well the covalent bond, valence band, all the forbidden energy gap. So based on the forbidden energy gap also we can explain something forbidden energy gap, energy level may be high or low. Based on that only your flux lines will move. It may be electric flux or it may be a magnetic flux. That media has to allow the flux to pass through it. That is nothing but it depends on the media. If it is a electric field, means we will term the ability of the media to pass the electric flux is called as permittivity. And if it is a magnetic field, if you are having a north and south pole, in between that we will have the magnetic flux. The magnetic flux will has to flow through some space. And that permittivity, ability of the media to allow the magnetic flux to pass through it is called as permeability. So these two things are important, permittivity and then permeability. Permittivity is epsilon, permeability is mu. And also again it is having a epsilon naught or mu naught mu r and all. That is absolute permittivity, relative permittivity. Similarly, absolute permeability, relative permeability. Let us see one by one. So if you are having two charges separated by a distance which is very large when compared to the S size, it is important thing. So Coulomb stated each and every term is important. It is separated in vacuum or free space. It is also important thing. Separated in vacuum or free space. It is also important. That the media is very, very important. It plays a vital role. And also the distance of separation plays the major role. It has to be large when compared to their size. Then there will be a force of attraction or force of repulsion between these two charges, and the magnitude depends on what factors. That is the main thing. So magnitude, because that force is a vector quantity, it is having magnitude as well as the direction. So the magnitude, it depends on what means? Depends on the quantity of the charge. That is the value of charge value. That is, it may be Q1, Q2, Q3 like that. So it may have some 5 microcoulomb, 3 picocoulomb like that. So that conversion also important. If it is here, millicoulomb means into 10 power minus 3. Micro means 10 power minus 6. So like that it is also important. Milli, micro, nano, pico, femto also. So 10 power minus 3, minus 6, minus 9, minus 12, minus 15. This is an important conversion while we are solving the problem in the gate exams. So it is also important. So it depends on the quantity of the charge value. Okay. And on which factor, addition or a product or a division, like that, means it is directly proportional to the product on the charge, that is Q1, Q2. That is force is proportional to the product on the charge, that is Q1 into Q2 into Q3, like that. So Q1 into Q2. And inversely proportional to the distance of separation. So if you are having both the charges are very closer, means the force of attraction or repulsion will be very high. If the distance is increased, means automatically the force of attraction or repulsion will be reduced. So it is an important thing. So your force is inversely proportional to the square of the distance. For example, if you are taking this a charge Q1 is a charge Q2, distance between them is capital R, means your force is proportional to Q1 into Q2 divided by R square. That is, the force is directly proportional to the product on each and inversely proportional to the square of the distance between them. That is, F is proportional to Q1, Q2 divided by R square. Okay. And whenever you are doing some proportional, you can remove it by introducing a proportionality constant. So F is equal to K into Q1, Q2 divided by R square. So what is that? F. F is nothing but the force of attraction between the charge Q1 and Q2. We know the unit of charge is Newton. And the second one is Q1 and Q2. So what is Q1 and Q2? Q1 is the charge value and Q2 is the charge value. It may be 5 coulomb, 5 microcoulomb, it may be in picocoulomb, any other things. The unit of charge is coulomb. And the next one is R. So the R is nothing but the distance between the two charges. If the charge value they will give and the distance between or is not the radius of the charge, distance between the two charges. Okay. And if they are given the charge values and the distance between the charge values, means we can find out the F. Provided we have to know about the K value. So K is called as the proportionality constant. So initially F is proportional to Q1, Q2 divided by R square. So we removed the proportionality constant by proportional symbol by introducing the proportionality constant K. So K is the proportionality constant and it is given by 1 divided by 4 pi epsilon. 1 divided by 4 pi epsilon. So we know very well what is epsilon. That is the permittivity of the media. Permittivity of the media. Epsilon. So if you are introducing the K value here, means we will get F is equal to Q1, Q2 divided by 4 pi epsilon R square. So this is the magnitude of the force between the two charges. So this K value is proven practically by Coulomb. And epsilon is the permittivity of the media. It is given by epsilon naught into epsilon R. Epsilon naught is absolute permittivity of the media and the epsilon R is the relative permittivity. So what is absolute permittivity and what is relative permittivity? So absolute permittivity is nothing but the permittivity in vacuum. Permittivity in vacuum is called as epsilon naught. That is absolute permittivity. It is constant because vacuum means we know very well it won't change. So there is no modification, there is no molecules, atoms, nothing. So it is a vacuum. So your epsilon naught value is given by 8.854 into 10 power minus 12 farad per meter length. So it is a constant. Epsilon naught value is constant, 8.854 into 10 power minus 12. And what is the relative permittivity? Permittivity of the given material relative to that of the permittivity in the vacuum. So it is the relative permittivity. That is, we are relating with the permittivity in vacuum. With that, the media permittivity. And if you are considering if it is placed in vacuum, means then only your epsilon R value is 1. Otherwise, in some media, there is a constant values will be given. That is epsilon R value 2 or 2.2. If it is a oil, if it is a normal atmospheric air, like that we are having the tabular column. Based on that, we have to substitute the epsilon R value. If they are placed in vacuum, means we have to substitute the epsilon R value is 1. Similarly, for the mu R value also. That is the permeability. Okay. And the next topic is Coulomb's law in the vector form. So why we are going for vector form? Because your force is a vector form. In the previous slide, coulombs given, F is given by Q1 Q divided by 4 pi R square. There is some force of attraction or repulsion between the two charges, but in which direction the force is acting? So there is no representation in this. So it gives only magnitude. So if you are having any vector quantity, you will have two parameters. One is magnitude and the direction. So this is the magnitude. And if you want the direction also means you have to go for the Coulomb's law in the vector form. So the same thing only, we are having the two charges, Q1, unit is coulomb, it may be of any coulomb, picocoulomb or millicoulomb or microcoulomb. Similarly, we are having one more charge, Q2, and the distance between the two charges, how we are representing here means R suffix 1, 2. Previously, the distance between the two charges, we have taken it as only R, but here we are taking the distance as R, 1, 2. And the next one is direction. So if you want to find out the force acting on the charge Q2 because of Q1, it is given by F2. That is, it is along the direction called as unit vector. Any vector can be represented by magnitude of the vector into the unit vector. Okay, so unit vector can be given by that vector divided by magnitude of that vector. In maths, we already studied all this. So this A12 is nothing but the unit vector. So what is a unit vector? In this direction only the force is acting. That is, if you are finding out the force acting on the charge Q2 because of Q1, the line joining is towards in this direction. So that F2. So what is F2? Actually in some books they will give F21. That is force acting on the charge 2 because of 1. They will represent F21 also. It is along the direction of the unit vector. That is where A12. This is a unit vector. Unit vector is nothing but that vector divided by magnitude of that vector. That's all. And how to find out this? If you are taking your R12. So, how to find out the R12? That is the distance between Q1 and Q2 means you have to take the origin. From the origin where the Q1 is located, from the origin where the Q2 charge is located. It is called as position vector. That is, R1 and R2 are called as position vectors. That is, R1 tells us where the Q1 is placed from the origin. And your R2 is gives the distance from the origin where the Q2 is located. So, R1 is the position vector of Q1, R2 is the position vector of Q2. So, we can see the triangle here. That is, from here to here and then here to here. It forms a triangle. So why the triangle is important means triangle along with the direction is very, very important for the addition or subtraction using the triangular law. So we are having in vector, we are having two types of addition. Triangular law of addition and parallelogram law of addition or subtraction. Anything we can take. So here it is also important. Why means we don't know the R12 vector because I know where the Q1 is placed from the origin. I know where the Q2 is placed from the origin. But I don't know the distance between the Q1 and Q2. So how to find out this? Using the triangular law of addition. So my ultimate aim is to find out the R12. How to find out the R12? Form a triangle. From here, it is from origin to the Q1, arrow it is here. Similarly, this is the charge Q2. It is placed from the origin in this side. So the arrow it is here. Now I am in need of force acting on the Q2 because of Q1. So how to join this? From Q1 to Q2, what is the force? So the arrowhead must be like this. So if we change the arrowhead means we cannot apply the triangular law. We can apply but we will get the wrong results. So the arrowhead is important. Now it forms a triangle. From this triangle, you have to start, now we can use the triangular law of addition. What is the triangular law of addition? If one vector is originated here, another vector is originated here, then the resultant vector is in the opposite direction. So obviously, R1 plus R12 is equal to R2. Okay, this is a triangular law of addition. But I know R1 and also R2. So now what is your R12? R2, this side R1 if it is coming on that side means it will become minus. So R2 minus R1. R2 minus R1 is my distance between the two charges. That is my R12. Okay. So this is your R12. and this is the F2. In this direction the force is acting. Now all are over. I know the magnitude, I know the direction. Now according to our Coulomb's law, F21 is equal to Q1 divided by 4 pi epsilon r square into the unit vector. Here the vector, unit vector is very important thing. It gives the direction of the force. So A12 is a important thing. How to find out the A12? Because we know all the parameters. We have to find out only the A12. So A12 is that vector divided by modulus of that vector. That is R12 divided by modulus of R12. In maths also we completed all these things in the vector calculus. So R12 using the triangular law of addition, R2 minus R1. Divided by the denominator also the same thing, but we have to find out the magnitude. That is the determinant value. That is magnitude value. Okay. In the GATE 2017, so there is one question. It is not related with the direct Coulomb's law application, but relevant to that one. That is, consider an electron. There is one electron. It is a negatively charged particle, and a neutrons. Neutrons have no charge. And there is a proton. Protons are positively charged particles. All these particles, see the order, electron, and then neutron, and then proton. This is the order of the charges. Initially at the rest, they are at the rest position. Electron, neutron, and then the proton. And placed along a straight line such that the neutron is exactly at the center of the line joining. That is, the distance between the electron to neutron and the distance between the proton to neutron are equal. Okay, 5 meters we can take. At the time t is equal to 0, what they are doing? Particles are released but are confined to move along the same straight line. So using some force they place like that. So if they are releasing that one, automatically it will go, because electrons are a negative charge, protons are positive charge, there will be a force of attraction. So it has force to move along the straight line only. Which of these will collide first? Which one will collide? Electron is there, neutron is there, proton is there. Option A, they are given the particles will never collide. Obviously it is wrong, because if they are supposed to move along the straight line, they have to hit. All will collide together. This is also wrong, because that positive, it may be having more protons, it may have more electrons, more positive charge, it may have less positive, like negative charge, like that. So it is also wrong. Proton and neutron. Let us see this one. And the next one is electron and neutron. Our option may be C or D, obviously. Now see the solution. This is the electron, neutron, proton. This is the order they are given along the straight line. So if they release the force, means automatically the electron will be attracted towards the proton, proton will be attracted towards the electron, because this is a negative charge, this is a positive charge. Automatically there will be a force of attraction. This force will act in this direction, that is from left to right, and this force will act from right to left. Okay. And which one will hit? Two options only there, that is proton and neutron may hit. That is proton and neutron may hit. Second option is, D option is electron and neutron may hit. That is electron may hit the neutron first. Which one will first hit the neutron? That is the question. Okay. So if you are taking the electron, means mass of the electron is very less when compared with the mass of the proton. And also the acceleration of the electron will be high when compared with the proton. So automatically it will be accelerated fastly and it will hit the neutron. That is, electron will hit the neutron first. Okay, this is the answer. So the option D is the correct one. Let us see the next question. GATE 2021 question. 1 microcoulomb point charge is held at the origin of the Cartesian coordinate system. So we know there are coordinate systems. That is how we are going to represent the charge in the 2-dimensional, 3-dimensional, means we will use the Cartesian coordinate system or rectangular coordinate system. It is nothing but the x, y, z plane. For example, you can take the corner of this wall. So x, y, and then z plane. So it is a 3D. This is called as a Cartesian coordinate system. Cartesian coordinates are x, y, z. That's all. Or otherwise we can use the cylindrical coordinate systems. r theta phi, or otherwise we can go for the spherical coordinate system. On a sphere we can represent. These are the three important coordinate systems in EMT. And they are placed in the XYZ plane only. So there is no confusion in that Cartesian coordinate system. If the second point charge, 1 microcoulomb is placed at the origin, that is exactly placed, you can take this. The origin means the charge Q1 is placed here and the value is 1 microcoulomb. Micro means into 10 power minus 6, we have to substitute. So 1 into 10 power minus 6 coulomb is placed at the corner. And the second point charge, what is the value? 10 microcoulomb is moved from 0, 10, 0 means, origin means 0, 0, 0. And this is a 10 microcoulomb. Second charge we are having 0, 10, 0. That is x is 0, z is 0, y is only 10. That is we can take, this is a y axis means 10. In this point we are having the 10 microcoulomb. Okay. And it is moved. Where it places next to 5, 0, 0. So exactly at the x-axis. Here you can take 5, 0, 0. After that, then the total, after that, subsequently, second question is 5, 5. That is x equal to 5, y equal to 5, z is equal to 5. After that only it will go to the 5, 0, 0. Which one? That 10 microcoulomb is moved from 0, 10, 0 to 5, 0, 0 via the 5, 5. Okay. So this is a question they are asking. What is the question? What is the work done? So some work has to be done against the force of attraction or repulsion. If you want to move the charges means we have to do some work. It may be against the force of attraction or against the force of repulsion. Some work has to be done. Okay. So how to find out the work done? And they are importantly they are given round off to the 2 decimal points. So whenever you are going for the exam preparation and all, we cannot able to use very frequently the calculators. That is 1 divided by 4 pi epsilon naught means what you have to do 1 divided by 4 into pi into epsilon naught value is 8.854 into 10 power minus 12. We have to find out. So it will time consuming. So to avoid that one, we can take the value as 9 into 10 power 9. It is also given in the question paper. Take 1 by 4 pi epsilon naught is 9 into 10 power 9. And they are asking the work done. That is, we are having the 2 charges, 1 microcoulomb at the origin, another microcoulomb at 0, 10, 0, and that point charge, that is 10 microcoulomb, has to be taken from the 0, 10, 0 to, what is the first question? 5, 5, x equal to 5, y equal to 5, z is equal to 5. After that, it has to place at 5, 0, 0. What will be the work done? They are asking. Okay. So how to solve the problem? So we know the formula. Q1 divided by 4 pi epsilon square into the unit vector. So this is a force formula. So work done means we have to do some work. We have to do some work against the force of attraction or repulsion. So that I am taking it as a minus. It may be of anything. Force of attraction means I have to do some work. If there is a force of repulsion means I have to bring it against the force. Okay, so some work has to be done, so I am taking it as minus. Remaining things are same as our Coulomb's law. Q1 divided by 4 pi epsilon naught square into A12 is our Coulomb's law. Just I am putting the minus. Why we are doing the minus? I have to do some work to bring the charge from 0, 10, 0 to 5, 0, 0. So I am putting the minus sign here. Some work has to be done. Substitute the value of Q1. It is at the origin 1 into 10 power minus 6. Substitute the value of Q2, 10 microcoulomb. Micro means into 10 power minus 6. So 10 into 10 power minus 6. And that 1 divided by 4 pi epsilon naught value is 9 into 10 power 9 into what we are having here 1 divided by R12 square into A12 square. That is, you have to find out the value. So how to find out? Work done is from the initial position to the final position. Initial position to the final position. That is from 10, 0, 0. What is the distance from the origin? 10 only. So take it as 10. What is the final position? I have to place it 5, 0, 0. Now what is the final distance between the Q1 and Q2? 5. General, we know that. So the limits are from 10 to 5 and I have to integrate. That is 1 divided by r square. So what that means? Integral of irradiance. So minus 1 divided by r square into the unit vector, that is our AR. 1 divided, what is the integral of 1 by r square? We know the formula, integration formula, integral of x power n into dx is x power n plus 1 divided by n plus 1. So use that formula, minus 1 by r, we will get minus 1 by r, and then substitute the limits from 10 to 5. So here we are having the minus in the formula already. Here we are having minus 1 by r. After integration, this minus and minus will become plus. So 90 to 10 power minus 3, 1 by upper limit minus lower limit. So this value will be 0.2, this value will be around exactly 0.1. So 0.2 minus 0.1 will get 0.1. 0.1 is nothing but 1 by 10. So that will get cancelled. So we will be getting 9. So 9 into 10 power minus 3. So whenever you are seeing this 10 power minus 3 means we can substitute it as a milli. So 10 power minus 3 milli, 10 power minus 6 micro, milli, micro, nano, pico. Minus 3, minus 6, minus 9, minus 12. So it's enough for us. So we'll be getting 9 into 10 power minus 3. 9 millijoules. So unit of work done is joules. So 9 millijoules we will get. So this is our answer. So actually in the question it is a numerical type. So we will have multi-choice numerical values like that we have to substitute. So previous one question is they are given the options. So we can check easily. So which one will be correct? We can do that. So this is a wrong answer. Maybe proton and neutron or electron and neutron we can guess. But in this case we have to give at least 9 point something or otherwise 8 point something. It may be around 8.8 to 9.2 means they will give the full marks. Otherwise negative marks will be there. So it is an important thing. And also it is not necessary to represent 0.009 and all. It is not necessary. We can give like that also. It is enough. 9 millijoule like that. Okay. Thank you for this section. We will see it in the next session. Thank you.